Welcome back to another video. Now we will discuss the remaining part, which is force between currents. It is the force between two current carrying conductors when they are placed close to each other. These are two current carrying conductors in both of which the current is flowing upwards. And if we were to find the direction of the magnetic field, we would find that the direction of the magnetic field is anti-clockwise in both of these conductors. Now you can clearly see that the magnetic field between both of these conductors is cancelling each other, as the directions there are opposite to each other. So the magnetic field in between both of these conductors will be weaker because both of the magnetic fields are cancelling each other out, but on the sides it will be much stronger as there's only one direction in the sides. Both of these conductors will attract each other. They will move from the stronger side to the weaker side. So in conclusion, we can say that when two current carrying conductors are placed close to each other and the current flowing in them is flowing in the same direction, then they will attract each other. We can show this through magnetic field into the page. We will see that they will attract each other. Both the conductors will attract each other. They will move towards each other because the magnetic field is weaker in between these two. As compared to the outside, it is much stronger on the outside. Now let's talk about an example where the current in between the conductors is going in the opposite directions. So similar magnetic field will be made in anti-clock direction, but here it will be clockwise. And as you can see that the direction in between these conductors is in the same direction and parallel. So the magnetic field in between them will be much stronger as compared to the outside. Now there's a strong magnetic field and both of these conductors will repel each other. They will move away from each other. As an example of this, we can consider a cross and a dot, and they will repel each other because one of the currents is reversed. So we have concluded that if the current is in the same direction, they will attract each other, and if the current is in the different direction, then they will repel each other. Basically, this is the scenario that we discussed. These are some points which are similar between magnetic, gravitational, and electric field. The first one is distance between masses, charges, and between wires. All three types of forces like gravitational, electric, and magnetic act between masses and between current carrying conductors. The second point says decreasing strength with distance from the source of the field. We move away from either mass or charge or the conductor. Force decreases with the distance increasing. It basically follows Newton's square law. For example, if we have two masses m1 and m2, if they move away from each other, distance between them is r. Force is inversely proportional to r square. Similarly in gravitational field and similarly in electric field, force is inversely proportional to r square. So all three types of forces decrease with the increase in distance between either charges or masses. The third point says that the field lines of each field represent the intensity of the field. If the field lines are closer to each other, then the field intensity is more, the field is stronger, and if they are further away, then the field is weaker. Now moving on to the differences between these three fields. The main difference is that we use different constants. For gravitational field, we use 6.7 into 10 power minus 11 Newton. Which is a much smaller force compared to 9 into 10 power 9 Newton, which is the constant we use for electric field. We can say that electric field is much stronger compared to gravitational or magnetic force. The constant for magnetic force is 2 into 10 power minus 7 Newton, which is similar to electric field, but it is still weaker than the electric field constant. So we conclude that electric force is the strongest force from these three, and gravitational force is the weakest from these three. Electric force is 39 times the gravitational force, so it is much stronger. If we think about atoms or molecules or particles, the nucleus of these is being held together by electric force, The electrons and protons are being held together by electric force, so it is a very strong force.